Okay, guys, let's go over projectile motion. And remember, projectile motion formula is going to be in the form of standard form of our quadratic function. So when objects are thrown, we're going to use this equation for feet, this equation for meters. And when objects are dropped, we're not going to have a velocity, so we're not going to have our linear term. So our first example is Beth dropped a ball 20 meters off a building. We're going to write the quadratic function and then all the key parts and interpret what these mean. So she drops a ball at 20 meters, so we know that we're going to use a negative 4.9 for our A value. And since it was just dropped and there was no velocity, we're going to say plus 20. So let's just draw a simple graph. I like to draw and keep a graph, a sketch. So we're going to start at 20 meters. So at 0 seconds, we're at 20 meters. And it's going to fall to the ground. So over how many ever seconds it hits the ground. This side of the quadratic is irrelevant because we're not going to consider negative time. So this is our height in meters over our seconds. So our vertex is going to be at 0 seconds. The object is 20 meters tall. So at 0 seconds, the object is 20 meters high. So our y-intercept and our vertex is the same. Now we're going to find out how many seconds it's going to take to hit the ground. So we're going to solve for x. Since we don't have a linear, we can use the quadratic function, or we can simply just solve for x. So we want to know at how many seconds is the height 0. So I'm going to replace y with 0 because our outputs represent height. So at 0 height, how long is it going to take for the object to hit the ground? So we're going to subtract 20. We're going to divide each side by negative 4.9. And we have x squared is equal, let me grab my calculator. And we get 4.08, and it keeps going. I'm just going to round it to 4.08. And then we have to take the square root plus or minus. And then in the calculator, I'm just going to, let's take the square root of 4.08. And that gives us about 2.19. So we have a positive and a negative 2.0199. So I'm just going to round this to 2.02. And we just want the positive one because we're talking about seconds. So at 2.02 seconds, so the positive root or the x-intercept, 2.02 comma 0. So this is seconds and this is meters. So at 2.02 seconds, the object is 0 meters off the ground. So that's when it hits the ground. Okay, let's take an example and let's say I want to know how high this object is in 1 second. So I want to know how high the object is in 1 second. So we're going to take our function and we're going to plug in, let's just go ahead and plug in the 1 wherever we have an x. So we have 1 squared is 1, and 1 times negative 4.9 is negative 4.9. And we're going to add 20. And so this is going to give us 15.1. 1. Just double check that. Yep. So in 1 second, the object is 15.1 meters. So we could say, since this is 2.02, 1 is probably about right here. So this is 2.02 seconds. We could call this 1. So we could say that like maybe right here on that graph. Okay, let's take a look at our second example. Zeke dropped his iPhone 40 feet off his balcony. Write a quadratic model to represent this situation. Okay, so we have another one where we do not have velocity. We're going to use -16 since we're talking about feet. And it starts at 40 feet off the ground. So again, I like to do a little sketch. We have seconds, and this is going to be feet. And so we'll call this 40. So at 40 feet, he drops the iPhone. And then we're going to find out how long it takes. So our vertex is also the y-intercept, the initial height. So at 0 seconds, the phone is 40 feet off the ground. So we're going to solve and find the root, the positive root, see how long it takes for the object to be 0 feet off the ground. So I'm going to replace 0 with y. And again, since we don't have a linear term, we do not have to use the quadratic formula. Divide by -16. And so 40 negative divided by negative is positive. So I'm going to get x squared equals 2.5. And then we're going to take the square root, the positive and negative. Of course, we're only concerned with that positive root because we're talking about time. So the square root of 2.5 gives us about 1.58. So this is 1.58. So I'm going to say the positive root at 1.58 seconds. The iPhone is 0, make that feet, 0 feet off the ground. And again, if we wanted to know how far off the ground was the object in 1 second, we would plug in 1. If I want to know, let's just ask this, how high off the ground is the object going to be, or how many seconds is it going to take for the object to reach, we'll say 30. So if I want to know how long is it going to take to be 30 feet off the ground, we're looking for x. So we'll just solve for x. Divide by -16. We get 0.625. Take the square root, positive and negative. We just want the positive root. And that gives us about 0.7. So x equals 0.79. I'll just round that to 0.8. So what does that mean? That means that at, what did we ask for? For 30. So we'll call this 30. At 30 feet off the ground, it took 0.79, or we'll round it to 0.8 seconds. Okay, let's look at our third example. Joe threw a football with a release at 2 meters with a velocity of 12 meters per second squared. So y equals, since it's meters, we're going to use -4.9, and then x squared, we do have a velocity this time, so times 12x, and he started at 2 meters in the air. So let's do our diagram. So we'll call this, it starts at 2, it's going to go up, and then come back down. So So this will be the positive root. This will represent how long it takes to hit the ground. This point is going to be how many seconds it takes to reach that maximum height. So let's find the vertex. So we're going to have seconds, comma, meters this time. So x equals negative b over 2 times a. Okay, so this is going to give us our seconds. So 1.2244, so I'm going to just say 1.22. So that's the seconds. So that's this value here on the graph. And now we're going to find the output by plugging that value of x into the equation. So the y part, negative 4.9 times 1.22 squared plus 12 times 1.22 plus 2. I'm going to just use parentheses and plug all this into my calculator. Now remember that the negative sign and subtraction are two different functions. And I get 9.346, so I'll say 9.35. So that's the maximum height, 9.35, and that is meters. So that's how you interpret the vertex. It takes 1.22 seconds to reach the maximum height of 9.35 meters. Now let's see how long it takes to hit the ground. So that's when y is 0. So at 0 meters off the ground, what is the x value? So I'm going to use the quadratic formula. Remember, when you use the quadratic formula, your equation must be equal to 0. Our a value is negative 4.9. B is 12. And c is 2. So x equals negative our b value plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I like to clean this up a little bit. So I have a negative 12 plus or minus. I square the 12, I get 144. Now I determine if this is plus or minus. So we have a negative times a negative, so that's positive. And now I just worry about multiplying 4 times 4.9 times 2. That gives us 39.2. And then negative 9.8 on the bottom. I'm going to add 39.2 plus 144. Go ahead and take the square root of that. So the square root of 183.2 gives me about 13.5. So we will have negative 12 plus 13.5 over negative 9.8. And then we'll have negative 12 minus 13.5 over negative 9.8. So this first one, when we do this, we're going to get a negative answer. So you can see negative 12 plus 13.5. That gives you a positive, and then when we divide that by the negative 9.8, that gives us a negative value. So that would be this value. That's irrelevant, but it was negative 1.5 about, or negative 0.15. Now this is the one that we are after, so negative 12 minus 13.5 divided by negative 9.8 gives us about 2.6. So I'm going to say about 2.6. So this value right here is 2.6. So the root, the positive x-intercept is 2.6, 0. That means at 2.66 seconds, the the football, I'm sorry, landed on the ground. So it took the football 2.6 seconds to hit the ground. So this 1.22 is how many seconds it took to reach the maximum height of 9.35 meters. Drew shot an arrow at a 5-foot release with a velocity of 150 feet per second squared. So y equals, talking about feet, so that's negative 16. Our velocity was 150 times the time, and he released it at 5 feet in the air. So we have seconds. This is going to be feet. We'll say this is the 5 where he releases it. It's going to be released and go up high and then land on the ground. This is our irrelevant root. We don't need that. So let's find the vertex. The x equals negative b over 2 times a. That gives us 4.6875. 4.6875. So I'm just going to go ahead and round that 4.69. And then we plug that in to get the actual height. So this is 4.69 seconds. And now we want to know how high that is, how many feet. Okay, and in the calculator it goes, negative 16, 4.69 squared, plus 150 times 4.69 plus 5, and that gives us roughly 356 says 56, and this is feet. So 356.56. So at 4.69 seconds, the arrow is 356 feet in the air or thereabout. Now let's see how long it takes to land. So we want to know at 0 feet, how many seconds does it take to hit the ground? Quadratic formula. Oh, guys, I almost forgot. That's a 0. Getting a little too quick. Okay, so x equals negative our b value plus or minus the square root b squared minus 4 times a times c all over 2 times a. Let's clean this up a bit. Okay, in my calculator, I'm going to go ahead and get the discriminant and take the square root of it all at one time. Well, I already have the square root, so I'll just get the discriminant and then take the square root. And we get 22,820 over negative 32. So we have x equals negative 150 minus that value. I'll take the square root in just a second. And then we have negative 150 plus that value. So 22820. That gives me about 151.06. I'm just going to say 151. And then this one is going to give me the negative. So I'm not going to work that one because we would have a negative. No, I'm sorry. Let's see. Yeah. Because we do keep change. And then that would give me, oh, let me just work that. That's the wrong one. Okay, let me just finish this out. .4. So this is going to be 9.40625, but we'll just round it to 9.4. So at 0 feet, it took 9.4 seconds to land. So this one gave us our positive answer here, which is that 9.4. This one would give us the negative answer because it would be 1 divided by negative 32, so we're not going to worry about that one. So this is how you find all the key features of quadratics with in context. Again, if they asked how many seconds it would the arrow be at, let's say 200, we would plug 200 in for y, and we'd have to use the quadratic formula, which means we have to set this equal to 0. So we would subtract 200, and our C value would be negative 150, and then you just go through the quadratic function, but you would get two positive answers because let's just say that this is 200 feet. If this is 200 feet, it's going to, the arrow is going to be 200 as it's going up, and then when it comes down, it will be at 200 feet again. So I would have two positive X values. So if they are asking for time, you plug in the height in for y, and then set it equal to 0 and use the quadratic formula. If they want to know how high the arrow was in 2 seconds, we could simply plug in 2 into our function to get the output. So I hope this helps.